Hello, let's continue our Sudoku adventure with Added Up by Sanabas. So we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. Because of these V's in the grid, the cells touching the V add to 5. So we could do, for example, 1, 4 here. These two add to 5, that's perfect. Do 2, 3 here, that would also work. All right, and we have 8 lines. So any 3 consecutive digits. So think about like entropic lines. So we're this group of 3, this group of 3, this group of 3, any 3 digits that are next to each other on the line must sum to 8. So for example, these 3 must sum to 8. So we could do 3, 3, 2. We're allowed to repeat digits. So 3 plus 3 plus 2 is 8. That works. But remember that these also sum to 8, and these also sum to 8, and these sum to 8. Right? Okay. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so I am going to put 1, 2, 3, 4 on these because that is how you add to 5. 1, 4, 2, 3. I'm thinking about adding to 8 in 3 digits. It is possible to use the 6 if we repeat a digit because we can do 1, 1, 6, but otherwise we can't. So this group of 3 here can't repeat a digit. So there's no 6. This also can't be a 6 because if this was a 6, we have to put a 1, 1 here, and those two can't repeat. So even though we could repeat a digit here and here, that doesn't help us place a 6 here. So this doesn't have a 6 on it. Because we can't do 6, 1, 1, 1 like that either. So I'm gonna highlight every cell that can't be 6, and I think that'll help us place some 6s, I'm hoping. These 3 can't be 6 because we can't repeat on that sum. These 3 can't be 6 because we can't repeat in this sum. Oh, that's interesting. Yeah, and these can't be 6 because we can't repeat in that sum. So the 6 in this box goes here. So now these can't be 6. And this, obviously, on the V, we can't have 6. And this can't be a 6. We said that can't be double 1. All right, so we actually aren't doing 6, double 1 on any of these lines. Rest of this column can't be 6. So it places 6 here. These can't be 6, so it puts a 6 in one of these two. 6 is in one of these two. Ah, this can't be 6 anymore. Whoops, whoa. So that places 6 there. That can't be 6, so 6 is one of these two. That places 6 here. Yeah, we don't need the colors anymore. So we placed a bunch of 6s. The remaining 6s are up here. Nice. All right, what else can we think about for summing to 8? So, right. Let's color this. Green, purple, orange. We know that green plus purple plus orange sums to 8. Now, this group of 3 must also sum to 8, but it's already got a purple and an orange on it. So we have to put green with it. We know that purple, green, orange adds to 8. And so if we have purple and orange already, we just need to add a green to that to get to 8. So that's going to be green. And then, yeah, so I think we still get the same cyclical behavior of entropic lines because now we have green and orange. What do you add to that? Well, you add purple, and then now we have to add an orange for these 3. All right, so we know that these 2 digits are different than these 3 because of the box. And so we can use red and yellow as our 2 other digits. Now, we need to repeat a digit. This has to be orange, purple, or green, but we don't know which it is. And then 6 is the non-color, I guess, the white. Okay, so we know that this is going to be red, yellow down here. I don't know the order. And this is not orange. So this is green or purple, I guess. So we know that red plus yellow is the same as like 2 of these added together. Orange plus purple, orange plus green is the same as these 2 added together. And so, yeah, I don't know exactly what to do with that yet, but it sounds interesting. These 3, how are we adding to 8? So actually, we can cycle now. Actually, we can keep cycling because whatever this is with the yellow, we need to put a red in there to add to it. So we're going to still cycle. We're going to go yellow, and then this is a green or purple, and in this column we already have a green. So we've actually proven it's purple. Very nice. And this red looks down, making that not red. Okay, so we know that yellow is a 1, 2, 3, 4 for what it's worth. I mean, 5 is the only other option, but it's not 5. All right. We might be able to do Sudoku on some of these digits. Kind of curious. Well, we know that this is a purple-red pair. That's where we have a purple red here and a purple red here. Yellow's over here somewhere. I'm trying not to like scatter the red too much. We know that orange isn't 6, so the orange actually is here. So we know orange is also 1, 2, 3, 4. I am wondering if we have 2 sums to 5 and purple is 3. Oh no, we can't do that. We need a 5 somewhere. Hold on. Let me think about this. So we know that red plus yellow is the same as orange plus green. Now that means we need 2 ways to sum to that digit. I think they have to add to 6, because if they added to 5, right? Okay, so we need, it sums to 7 or less is the first thing we should note, but it can't sum to 4 or less because there's only one way to add to 4. There's only one way to 3. So like we can't do a 1-2 pair and a 1-2 pair, or 1-3 pair and a 1-3 pair. So we're adding to either 5, 6, or 7, but 5 doesn't work because we'd have to use up the 1, 2, 3, 4 for that. And then that leaves just 5 in this box, but we know that a sum to 5 plus 5 is 10, not 8. So we sum to 6 or 7, meaning that purple is going to be 1 or 2. First of all, purple's a 1 or 2. Oh, by the way, that means this isn't 6. Oh, sorry, earlier I said this was red purple hidden pair, so that's not 6. So that's a 6 and that's a 6. We can place those. Oh, and that means this is 5 for the column. No, sorry, I penciled this 1, 2, 3, 4 as a demonstration of what wouldn't work. Don't leave that in. So we either add to 6 or 7. Let's think about it. If we add to 6, then we need to use 1, 5, and 2, 4. And that doesn't work because if I'm using 1, 5 or 2, 4, the 3 is left behind, and 6 plus 3 is 9, so that doesn't work. So I need to add to 7, meaning that these are all 1s. So purple is 1, which means that this is a 2, 3 pair. So yellow is 2, 3. This sees a 1, so that's not 4. Orange is not 1. I have a 2, 3 pair here. Orange and green. Oh, green is placed in this box. So green is the 2, 3. And these are 4, 5. So red is a 4, 5. And this is the other, orange is the other 4, 5. Oh, but orange can't be 5. So orange is 4. 4 plus 2 is 7. That makes that 8. That's 3 and 5. That's not 8 though. I did something wrong. Hold on. This is 4. 4 plus 3 is 7. This is 2 and 5. Okay, I did it correct this time. All right, that's 5. That's 5. That's a 1. We know 1 is purple. That's a 4. This is a 2. That's a 3. Okay. And then this isn't purple, so that's 5, that's 1. And now I don't need the colors anymore. I think they're getting in the way. So these add to 8. So these 2 add to 4. They could be 2 plus 2. Well, you can't put a 1 on them, so they have to be 2 plus 2 because they can't be 1, 3. So the 2's go there. And then this is a 3. Okay, this is 3. This is 5. That's 5. All right, 3 in the corner. Nice. That's a 2. We can just finish up. 1, 2. We need 3 and 4. And then here we need 3 and 4. So this is our 3, 4, 3, 4, and we're done. All right, cool puzzle, Sanabas. I liked figuring out that had to be a sum to that the shared sum was 7. That was neat. And that the lines were still cyclical. I probably should have figured that out right away, but it was neat reproving that they had to be cyclical. But yeah, that's cool. All right, well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.